Yes, you do.
What's up?
What's wrong with me?
Oh.
What'd you do?
I said, he said thank you, and I said you too.
Instantaneous. Thank you, sir. You too.
Oh, God.
It's like when you're checking out the cashier, and they say thank you for shopping with us, and you go, thanks you too.
Yeah. Well, maybe they do shop there. And they're contributing to the overall facet of society. Maybe. Maybe it's a drug dealer public, but they're working part-time as a cashier, and they're really making hundreds of thousands of dollars per year selling ecstasy. Who knows?
Money laundering.
We're not gonna get this guy. Part-time cashier.
Who are we? We're just students making,
Not that I ever thought about that.
just making assumptions.
Do you have any spare of the thing, of the packets I have one for some odd reason?
Thanks. Thank you, Mr. Doe. Your enthusiasm reinvigorates me.
This kind of day really, just gets you going.
Yeah, I hear you. It's in there somewhere, right?
Yep.
You too. You missed that part, did you?
You too?
Yeah.
What am I welcome for?
No, you didn't do anything. John came up, he gave me his assignment, and I said, thank you, sir, and said, you too. So then a few other people said it out of hilarity. It was strikingly funny.
Angry.
I concur.
Yeah.
I thought it was funny. I just can't really say.
It's a bad day.
Smile.
No. Got bit by a spider.
Really?
Got a fever.
Do you know what kind?
I don't know, but they took a blood tox today and said I was moderately okay. They said I probably shouldn't go to work, but
Yeah, you probably
should have, but I feel
Take a
bad.
whole lot of painkillers
Not one.
for the fever.
Nope, nothing.
You should.
They gave me amoxicillin. That's it.
Yes, but that's not a fever down.
Oh.
That's what I mean.
Yeah.
Tylenol, ibuprofen.
Oxycodone. Yeah.
That one, yeah, that would do it.
I had hydrocodone
That's a C3. Nobody wants C3s. You want the good stuff. You want to play with the pills, you play with C1s.
Where were you when you got bit?
Who knows? I got bit 3 days ago. And I was like, oh, this isn't that nice. And then yesterday it was like, that looks okay. And then I was like, today, boy, that really hurts the wall.
Because it's on
And I took my time to
your
check
chest,
it.
like they.
It's on my leg. Yeah.
Yeah.
So I was actually hoping that they'd slice me open and get whatever's in there out.
But there's nothing in there.
Oh.
Other than your body. I'm saying, there's something in there, but it's just your body reacting.
Yeah, but it actually physically hurts my skin because it's so swollen.
Like a spider bite?
I guess, whatever it is. I'm not, that's why I do math and not zoology.
I would figure by now you'd figure out if it was a ground post. That would be pretty
It's
bad.
not.
But
I'd be probably dead.
yeah, I figure it's more spider bite.
Yeah.
Can I get a last glasses?
I would let you, but 2 people asked for them, and
Okay.
they lost. I'm sorry.
Okay.
Sorry. If I had them, but you can share.
Okay.
If I had another one, I would give. If you want to, There's 2 minutes. So if you want to, you can run over to the Aberdeen, the computer center, you might be able to print one out if it's that important.
I mean, I could just take pictures of his.
That's true. We could do that. That'll work.
I never seem to know that.
I think John will let you.
Because I never see that.
Well, I don't know.
Very useful.
So if I fall over to a class, that's automatically back to the one.
So I have hot
Is it hot water?
So then I say like, okay, this is for.
Is it vodka?
No, it's just water. Does
that
still count as a drink?
Everything's
No,
like
balls.
and everything.
I might come up and punch you in the face. Yeah. Either way.
It's heavily filtered water.
Heavily distilled vodka.
Yes.
That's what's up. Thank you, Mr. Lucas. Have a nice day.
I'm sure I'll find you.
I always go by the satellite clock.
We should go by like London time.
I should go by whatever I feel like. So I should just show up at 3:05 and start teaching.
There you go. Half the professors do it anyway.
That might be a little bit weird.
That's half the school.
I actually did that by accident for a half a semester in pre-calc. I showed up 10 minutes early, and I really thought the class started at 10:25, not 10:35. The good news is everybody was always there, so nobody told me anything until like halfway through the semester. They're like, you know, this class does start at 10:35 or 11:35. Didn't know that, but now I do.
You were showing up over an hour early at 10:30.
Oh no, like
And everybody was there.
yeah, people were.
And there was another professor in there too. You just kicked him out every time.
No, it was the oddest thing, and it worked out because we got out 10 minutes early. Okay, guys, just a heads up and a reminder of what's going on. Okay, we're going to finish up graph theory today, hopefully, right, depending if I fall over or not. And make sure that for Monday, if you have any questions for me about the final exam, you can bring those to me. I'd be happy to answer whatever I can. I'll just outline what's going to be on the final like I usually do for the exams, and you guys can ask me questions that you choose. Okay. Right. And then on Wednesday next week, if we finish up everything for the final, I'll be available for individual assistance. I'll just either sit in the room or sit in my office and just assist. But if you guys feel like you're comfortable with the final, then we don't have to show up to class on that Wednesday if you don't want to. Okay? For the assignment, just take a picture of it and send it to me by 3:15 p.m. so I can do something. All right. So if you don't want to come to campus and you don't have class, all right, you can email this to me. Okay? Or you can just drop it all to me, whatever you guys want to do, make a paperwork. What's that, sir? Oh yeah, you can give it to me Monday if you guys are done with it, I don't care. But I'll make it due Wednesday, so that way if you guys need an extra day or two, then that's fine. Okay. And then our final exam is going to be the Wednesday the 14th. It's the 2-hour examination block, so I just made it scheduled for that time. Okay? So everybody clear as to what's going on, guys? Any questions before we get started with more graph theory stuff? Okay, so we're getting there. We're close. Okay. I think last time we talked about complete graphs and bipartite graphs. So the next, I guess, logical thing to talk about is the difference between a path and a circuit and a walk and those sorts of things. Okay, so we have our definitions. Basically, a walk is anything goes. Okay, so if I talk about a walk from one point or from one vertex to another vertex, it's any sequence that you want to end up and begin on the same vertex. Okay, so walk is the most, I guess, free or liberal or forgiving type of traversal of a graph. Closed walk basically means you begin and end on the same vertex. You could bounce back and forth between the same vertex a million times if you wanted to. It's still a closed walk.
So a walk is like from all the vertex?
Yeah. No, it doesn't have to be all of them. Like for example, if I wanted to do a walk from 1 to 5, I could do 1, 3, 5. I could do 1, 2, 5. I could do 1, 2, 5, 2, 5, 2, 1, 5, 1, 5, 2, 1, 5. A walk is anything I want it to be. Doesn't matter. It doesn't have to be the original route.
Okay.
Okay. Walk is just definitive, a traversal. Closed walk means you start and begin on the same. A path means you can't repeat edges. Okay, so that's where it starts to get a little bit tougher to work with the traversals. So you can't repeat any edges. Simple path is basically going to be a path with no repeated vertices, okay? So path has no repeated edges, simple path, no repeated vertices. Some of you guys, I think last time, might have confused a circuit with a loop, okay? A circuit is basically going to begin and end on the same vertex. So in other words, it's a closed walk, but you can't repeat edges, okay? So it's different than a loop. A loop is basically one edge, you begin and end on the same, but you only do one traversal, okay? Circuit, you can just do as many as you want. Simple circuit is the most difficult. Circuit that does not have any repeated vertices except for the first and last, okay? So basically, I went from the most free, if you would, or the most forgiving, down to the least forgiving, okay? So what I wanted you guys to do is just go ahead, we can define a few of these. So I want to try to find a path from 1 to 4, okay? We go up to the definition of path. Path basically means no repeated edges, okay? You can just name the vertices if you want to, since each vertex is only, I guess, joined by adjacent to one edge. Right? So if I want to go to 1 to 4, all right, what's one possible path that I can use?
V4, V5, and V1?
Well, it would start at 1.
Oh yeah, just to start one.
It starts at 1, so we'll go from 1 to 4.
Oh, so V1 to the 4, right? So
Yeah, we
that's
could do
V1.
1 to 1, excuse me, V1, 2, V2, 5, V3, 4. That's certainly one possible path.
That's a walk you're talking about?
No, this is a path.
Oh, okay, so a
Okay.
path in general, a path is, that contains the vertices and the edges.
Well, it just, you can't go back over vertices. Or, I'm sorry, you can't go back a path, you can't go over edges. You can't repeat edges. So once you've gone over that edge, you can't repeat it, okay?
So why do we care about the vertices then?
Well, we have to denote which of them we're going through in case, for some reason, you have some sort of vertex or you have an edge that might go to somewhere else that, it just makes it more
Okay.
definitive.
Alright.
Okay? So for instance, we could say for letter A, we could say 1, comma, V sub 1, comma, 2, comma, V sub 2, comma, 5, comma, V sub 3, comma, 4. Okay? So, or you could just do the vertices, I really don't care, okay? The only downside to that is if you start having parallel edges, then it might matter in that instance. But because none of the edges are parallel in this graph, we don't have to worry about that. Okay? Does that make sense, guys? It's as easy as it gets. Okay. Find 3 walks from 1 to 2. All right, this one you can't really get wrong. Okay, well you could, but that'd be embarrassing. What's the easiest one?
V1.
Yeah, 1, V1 to 2, right. So 1, comma, V1, comma, 2. So that's one of them, okay. Another walk from V, or 1 to 2 would be what, guys?
V6, 5, V2, 2.
Yeah, so 1, V6, 5, V2. So 1, V6, 5, V2, comma, 2. Okay. If I really wanted to, I could repeat some of the edges. So I could go 1, comma, V5, comma, 1, or I'm sorry, comma, 3, comma, V5, comma, 1, comma, V1, comma, 2. All right, so, and like we say, guys, a walk can be anything it wants to be. All right,
What you write? 1, comma, V5.
V5, comma, 3. So 1 to V5 to 3 to, this should be V5. That's a 5 in English, so. And then 1, V1, 2. Okay, does that make sense?
Yeah.
Okay.
V2, 5.
So you like went over the back then?
Yeah, with a, and remember, with a walk is
V-
anything it wants to be. Okay, so look at your definitions, guys. Definitions are going to tell you what you have to do, or what you're allowed to do, and what you're not allowed to do. Okay? And then finally, if I want 2 circuits from 1 to 1, obviously.
I think you got it, the last one. Hold on a second. 1, comma, V5.
Yes.
Then
comma,
3,
comma V5,
3, comma,
V5.
What is V5 again? Hold on a second.
Yeah, same thing.
Oh, okay, you're coming back. Okay,
comma
okay.
V5, comma 3, comma V5, comma 1, comma V1, comma.
Okay, gotcha.
Okay?
Uh-huh.
For C, find 2 circuits from 1 to 1. So I think the easiest one would just be 1, V6, 5, V2, 2, V1. Remember, a circuit basically says you have to begin and end, and you can't repeat any of the edges, okay? So that would be 1, comma V6, comma 5, comma V2, comma 2, comma V1, comma 1. Okay, so that's one possible circuit.
Circuit.
Another one you could do, you could just go on the outside or the perimeter.
Comma V6.
So 1
Uh-huh.
to V6
Okay.
to 5 to V2 to 2
Oh, and
to
then comma.
V1 to 1.
Okay.
That's a
then.
circuit. You just go and you begin and end on the same. Okay,
Okay.
does that make sense?
Mhm.
Okay. So that's one possible circuit. And then for the other one, you could just trace the perimeter if you would for this. So we could do 1, comma V5, comma 3, comma V4, comma 4, comma V3, comma 5, comma V2, comma 2, comma V1, comma 1. Okay, so any questions I can answer, guys, about how you guys are going to do the traversals and the 6 different possible traversals for a graph? Okay, really easy stuff. Look at the definitions. The definitions are going to tell you what you're allowed to do and what you're not allowed to do. Okay. All right, specific types of circuits. Okay. Okay. So an Euler circuit is essentially going to be any graph G. Okay. It contains every vertex and every edge. Okay. Remember, with a circuit or any circuit, you can't repeat edges. Okay. You can repeat vertices, but you can't repeat edges. Okay. So let's make sure. I'm sorry. You may repeat vertices. Okay. But not edges.